All right, so we're going to start by talking about reciprocals. And there's this little tiny box over here, so let me zoom in so we can kind of see it. So it's all about reciprocals. Two numbers whose product is 1 are reciprocals. So it's just filling in that vocab word in the space. It is a small space, so you have to write small. To write the reciprocal of a number, write the number as a fraction. So that's the next blank. And then flip the numerator and denominator. So to find the reciprocal, you have to have it as a fraction, and then you just flip it upside down. So it says we're going to write the reciprocal of each number. So these are all set up as fractions. All we do is flip them upside down. So the reciprocal of 7/8 would be 8/7. Reciprocal of 9/11 is 11/9. The reciprocal of 5/2 is 2/5. And the reciprocal of 6/13
is
is
13/6.
Shh, please do not interrupt. We're recording. All right. So all of these are the reciprocals. We're just flipping the fractions upside down. Now, down here it says we're going to talk about special reciprocals. So it says we have to write them as a fraction before we can flip them over. We just want a numerator and denominator. So how can I change 3 to a fraction? Raise your hand if you know. Winter. Okay, so you could change this to a fraction by making it 3/1. And then the reciprocal would be 1/3 to turn it upside down. So that's how you can do whole numbers. Okay, now to do 4.5. Shh, I can't do reciprocals with mixed numbers. So I have to change it to an improper fraction first. So we take 2 times 4, which is 8, plus 1 is 9. So this is the same thing as 9/2. Remember, we don't keep the 4. We're trying to get rid of that. We just changed it to an improper fraction. It's the same thing, 9/2. And then we can make the reciprocal by flipping it over 2/9.
That is so much fun. Is there any reducing?
There could be, but if this is reduced, then that won't be a problem usually.
Right.
So there might be. You'll just have to see. Okay, 1/4 doesn't look that weird. It's a fraction. If I flip it over, I get 4/1. What's special about that? Raise your hand if you know. Bennett.
That's a whole number.
It would just be a whole number 4. I wouldn't have to leave the 1 underneath. So those are just some special cases. Now we're going to use reciprocals when we divide fractions. So we're going to see why this is going to be helpful up here in this next part. So I'm multiplying 2 fractions, 3/4 and 4/3. And I'm going to use cross canceling. I have a 3 and a 3. 3 divided by 3 is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. 4 divided by 4 is 1. I'm going to get 1/1, which is 1. When you multiply reciprocals, that's the definition of a reciprocal, is if you multiply 2 numbers that are reciprocals, you get 1. So down here I have 1/4, and they have 4. 4 is the same thing as 4/1, and those would also cancel. The 1s are okay, and then I can divide the 4s by 4 and get 1 and 1, and you get 1. So when you multiply 2 reciprocals together, everything cancels, and you get 1. Okay? So that's what goes into those blanks. Shh. We don't need to have any outside talking right now. Okay, so dividing fractions just has one more step than multiplying. And we're going to talk about that down here where it talks about dividing fractions. So it says dividing fractions. To divide by a fraction, change the operation to multiplication and then multiply by the reciprocal of the fraction. So there's another way to remember it. And this is what we used for subtracting integers, so I don't know how I feel about using it again. But the person who wrote this little box did a keep, change. Dr. Nichols also had a method that she called copy dot flip. that I can talk about a little bit too. So this did not copy really well, but it says 3/4 divided by 2/5. If you can't see that division symbol, let's write that in really quick. And so instead of keep, change, change, I don't know if I really like that. I kind of like the one that Dr. Nichols used, that's just copy dot flip. And so I'm going to talk about that. So the first number, you just copy down. So 3/4, we just copy that down. And then we change division to multiplication. So you just put a dot. And then the last fraction, you flip. We change it to 5/2. And so that's the flip.
It's amazing.
And then this is the dot. So you copy the first fraction, you put a dot, you flip, copy, dot, flip. If you like that, we can use that. A lot of my high school students had Dr. Nichols when they were in middle school, and that's the way that they learned. And so I still talk about it that way when they get confused, because fractions still show up later. All right, so I would inspect this. Now it's multiplication. It's the exact same thing we did in the last lesson. I can look and see if there's anything I can cross cancel. So 3 and 2, no. 5 and 4, no. So if that doesn't work out, then we just go back to the old-fashioned multiply across. 3 times 5 is 15. 4 times 2 is 8. And then I have to change that back to a mixed number. So I'm going to go over here in the margin and do that so it's not inside my box. I'm going to take 15 and divide by 8 really quick. Will 8 go into 1? No. So I'm going to scoot over and do 15. How many times will 8 go into 15? Yes, one time. So that 1 goes above the 5 because it's going into the 1 and the 5 together as a number as 15. So then 1 times 8 is 8. 15 minus 8 is 7. And because I'm already at the end of this number, I can go ahead and do my fractions. So the 7 and the 8 make 7/8. So that's what my answer is going to be, 1 and 7/8. Okay? So that's basically what we're going to do. We're going to copy the first fraction, change it to multiplication, flip, and finish it out.
Can I use your question?
Yes. Okay, so let's look at our division problems over here. So find the quotient. That just means we're dividing. So I'm going to put in the parentheses over here, copy, comma, dot, comma, flip. Copy, dot, flip is a good way to remember it. So when you do these, you do not change the first fraction. That's why I like this copy part. You just copy the first fraction down. We're going to change division to multiplication. So you just put a dot, and then you flip the last fraction and make it 3/4. Okay, so I really want to encourage you to use the cross canceling because it'll make things easier. What could we cancel out here before we multiply? Go ahead.
Everything.
Okay, so everything can cancel with everything. So give me an example. What can we cancel out?
3 and 3 can make 1.
Okay, so 3 divided by 3 is 1. 3 divided by 3 is 1. What about the...
4 can be 2 and 2 can be 1.
Okay, so we're dividing by 2 then. 2 divided by 2 is 1. 4 divided by 2 is 2. And now I just have 1 times 1 and 1 times 2, and we get 1/2. And if I cancel the fractions over here, I don't have to do it on my answer. It is already simplified as far as it can go, and I'm done. You always want to check just in case you mess something up to see if you could simplify. But if you simplify everything over here as much as possible, then this will be done. Okay, let's look at the next one. So we're going to copy the first fraction, 5/8, change division to multiplication, and then 1 over 4 will become 4 over 1. I am just going to leave that as a fraction right now because I need that to do my cross canceling. Okay, so the 5 and the 1 are okay. Can I do anything with the 4 and the 8? Yes. So I can divide them both by 4, right? So 4 divided by 4 is 1. 8 divided by 4 is 2. Be careful, make sure you're dividing, not subtracting. And then we multiply across. So 5 times 1 is 5. 2 times 1 is 2. Now normally they want us to change this back into a mixed number. So you see how there's a little bit of space up here under that other flap? I'm going to do that up here. I'm going to take 5 and divide by 2. to change it into a mixed number. So 2 goes into 5 how many times? 2, because 2 times 2 is 4. And then I get 1. And I'm all done with what's inside, so then I just have 1/2 left over. So this would be 1 and 1/2. I'm sorry, 2 and 1/2. I copied that down wrong. You gotta watch me. Thank you for paying attention. So 2 and 1/2, because that's what I wrote up here. So I'm just kind of using the little margins and spaces to work that out. Okay, let's do the next one. So 3/7 we just copy down. We're changing the division sign to a dot to multiply. So copy dot, and then flip, we have 14/2. Now some people are going to look at this and go, oh, I could reduce the 14/2. You can if you want to. A lot of times it's more beneficial to go across and cross cancel this 14 with the 7. As long as you're reducing it somewhere, it'll be fine. So I'm going to do the 14 and the 7. So 14 divided by 7 is 2. 7 divided by 7 is 1. And then I can check and see if there's anything else that can be done. So if I wanted to, I now have 2 over 2. What is 2 over 2? Just 1. I can reduce that a little further if I want to on that step. And then I just get 3 over 1, which is 3. If you didn't do that second one, you would end up with 6 over 2, which you can also see easily makes 3. So the simplifying can happen here, or it can happen on the answer. I like to do as much as possible over here before I multiply, because then you're not multiplying big numbers. Especially thinking about the test coming up later this week. You won't get to use a calculator. So you want to make sure the numbers are as small as possible. Okay, so on this last one, I have 3/4 divided by 4. We need 4 to be a fraction. So how do I change 4 to a fraction?
4 over 1.
Put it over 1. Okay, and then I'm going to copy dot flip. So I copy the first 3/4, change this to a dot, and flip 4 over 1 to 1 over 4. So I was excited in the beginning and thought I could cancel the 4s, but once I flipped it, I really can't. There's nothing that's going to cancel. So I'm just going to have to multiply across. 3 times 1 is 3, 4 times 4 is 16, and that doesn't simplify. It doesn't reduce, so we're all good. Okay, one more of these. All right, so I've got 5 divided by 2/3. So the 5, we need to change to a fraction. So we'll do what we did before and change it to 5 over 1. And then once I've done that, I will copy that down. 5 over 1, change it to a dot, that's multiply, and then flip 3/2. Copy, dot, flip. Is there anything that'll cross cancel on this one? No, so I'm just going to have to multiply across. 5 times 3 is 15. 1 times 2 is 2. So I've got 15/2. So 15 divided by 2, I'm just going to do right here. So how many times will 2 go into 1? No, it'll go into 15 though. How many times does 2 go into 15? Go ahead. 7 times. So I'll put that 7 here. 7 times 2 is 14. We subtract and get 1. So that gives me 7.5, which is my final answer. Okay, I know you guys are getting restless, and this is going to be the short version of this lesson. So we're going to shorten down the right half side, but I'm not going to skip everything, okay? Because I feel like it's important that you see a few mixed numbers and some whole numbers and a little bit of story problems. So we're going to fill in a little bit of this part. I'm going to focus on the story problems a little bit, but I want to get these blanks filled in so that we have some steps. So to divide mixed numbers, write each mixed number as an improper fraction, just like we did with multiplying. You've got to make it just a numerator and denominator before you can do anything else. Then divide as you would with a proper fraction. So after that, everything's the same. Remember to keep the first fraction the same. Change division to, I'm just going to put a dot there for multiply. Write the reciprocal. Sorry, I don't know why it's doing that. Probably because I'm moving. Write the reciprocal of the second fraction and then simplify. All right, so let's do, I'm going to do one of these, and we're going to do 2 story problems, and then we'll call it good, okay? So I am going to shorten this down a little bit. So let's start with this first box. I've got 2 1/4 divided by 3/8. So the first thing I have to do is make 2 1/4 into an improper fraction. So raise your hand if you can help me do that. Rylan.
So you change 2 to 2/1, and then that's how I do it.
Okay, so it's probably not, so tell me, what do you think?
2 times 4.
Okay, so we're just going to take 2 times 4, which is 8, plus 1 is 9, and then I have 9/4. Which is the way most of us are thinking of it. It doesn't mean that what you are doing is wrong. That's just the way most of us think about it. And we're going to keep that number, so I can just leave that sitting there. So it isn't exactly copying on this step, but we just changed this number to the improper fraction. It's fine. And then we're going to change division to the dot for multiplication, and then flip and make that 8/3. There's a lot of stuff here that we can cancel, so let's focus on doing that. So the 9 and the 3, I can divide both of those by 3. Go ahead, Brian.
Can I get a tissue?
Yes, you can. So 9 divided by 3 is 3. 3 divided by 3 is 1. And then 8 and 4 can both divide by 4. So 8 divided by 4 is 2. 4 divided by 4 is 1. And this one's going to come out a whole number. I've got 3 times 2, which is 6. 1 times 1 is 1. So we just end up with 6. If we had an improper fraction, we would do our long division again and switch that. Okay, so rather than do a whole bunch more of those and then do story problems, I'm going to skip down and do some story problems down at the bottom. And we're not going to have time to do all of them, so I'm going to pick on the ones that have mixed numbers, because the process is basically going to be the same. So I'm going to go over here to the right-hand side where it says after lunch. Does everybody see where we're at? We're all good? Okay, so after lunch, there are 3.5 pizzas left over. Each serving is 1/8 of a pizza, which just means they cut the pizza into 8 pieces. How many servings are left? So we have 3.5 pizzas. So if you need to, you could draw a quick picture. 1, 2, 3 pizzas, and then there's half of a pizza, okay? And each serving is 1/8 of a piece. So what we're doing is we're taking these 3.5 pizzas and we're imagining them divided into 8ths. So I can make quarters and then 8ths. Did you guys see I do that? So you draw a line up and down, that's halves. Draw a line across makes 4ths. And then if we make the 2 diagonal lines, that's 8ths. Do the same thing here. And then we have to kind of imagine this half a pizza is doing that. So it would have 4 pieces instead of 8 because it's a half a pizza. So basically we just sort of illustrated it, and you could, with the picture, count the pieces. But let's talk about what this looks like if we're actually writing a number sentence. So we're starting with 3.5 pizzas, and then we're cutting them up into 8ths. When you're cutting something up, you're splitting something into equal pieces. That's division. Okay, that's how I know this is a divide sign. And I'm dividing it into 8ths. All right, so we can do what we did with this before. So if I have a mixed number, you got to change it to an improper fraction first. 2 times 3 is how much? 6 plus 1 is 7. Some of you were trying to write down this whole number after we did that. Once you have this into an improper fraction, the whole number goes away. So that's that first number. We didn't exactly copy it, but it's still the same. We haven't flipped it. And we're going to change this to a dot. We're changing it to multiplication. We're going to flip 1/8, make it 8/1. Okay? Now, can I cross cancel anything?
Yes.
What can I do?
8 and the 2.
The 8 and the 2. So we can divide both of those by 2. So 8 divided by 2 is 4. 2 divided by 2 is 1. So 7 times 4 is 28. And 1 times 1 is 1. and I get 28 pieces. Now, a good way to check this would be to go back to that picture that I was drawing. I have 8 pieces, 16 pieces, 24 pieces plus 4 more, 25, 26, 27, 28. This is 28 pieces of pizza over here, and I can check to see if I did this right by using a picture and making sure that I totally understand the question. Okay? So, and it should be bigger. So what happens if we divide this up? Because we're looking at how many little pieces. We're dividing it into 8s into little pieces, but then we have a lot of pieces of pizza, and that's why this number is bigger than the fractions. We're going to do one more. Okay, we're going to come down here. This is making me hungry. We're talking about food.
My goodness.
I don't know why. Okay, a cookie recipe requires 1 3/4 cups of flour to make a batch. How many batches can be made with 10 1/2 cups of flour? Please stop. Okay, so if we're going to have 10 1/2 cups of flour, you might be imagining these as little circles. So I'm going to draw these really small. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there's half of a cup. I'm going to make that look like half a circle. So I'm looking down. I don't know. I just drew them as circles because I did. You could make squares. Use any shape to represent this. Okay, so I need 1 3/4 cups to make a batch. So in order to figure that out, I need to have these written in quarters. I need to have fourths. So I could divide these all into fourths to kind of figure this out, okay? And I'm going to come back to that picture in a second, but I'm just thinking about it in my mind that I'm going to divide these up, okay? But I'm going to do that in a second. Let's write our number sentence. So how many cups of flour do we need total?
Well, that's how much we have.
Oh, this is how much we have. Okay, so I guess this is how much we're going to make because that's how much we have. 10 1/2. So I'm going to take these 10 1/2 cups and then I'm going to divide them into batches that require 1 1/2 cups. Okay? So the first batch is going to be this cup and half the next one. Oh, 1 3/4. You're right. I wrote down 1 1/2. I meant 1 3/4. So I was starting to do that wrong. Okay, helps to reread the question. I've got 1 3/4, 10 1/2. So stay focused with me. This is the last one. So we're going to change 10 1/2 to an improper fraction. So can anybody tell me what that improper fraction is? Sam.
21 over 2.
21 over 2. So 2 times 10 is 20 plus 1 is 21. So 21 halves is correct. What do I do next? Raise your hand if you can help me out. Brian.
You change dividing into multiplying.
Good. Change dividing to multiplying. And then who wants to tell me what this will be if I change it? Oh, you know what? I just realized we have to change this before we flip it. So we're going to change this in an improper fraction first. Do you want to do it, Tommy?
It's
7/4. So I need to write that over here. And then that number has to get flipped down here. So instead of 7/4, I'm going to flip it, make it 4/7. Can I cross multiply anything?
Yes.
Or cross cancel, I mean. I'm having trouble saying my words. Go ahead.
You can cross cancel the 7 and the 21.
Okay, so 7 and 21. So 7 divided by 7 is 1. 21 divided by 7 is 3. And then the 2 and 4 we can also do. 2 divided by 2 is 1. 4 divided by 2 is 2. If you do all the simplifying up front, you won't have to reduce your answer, and you get to work with smaller numbers when you multiply. I get to take 3 times 2, which is 6. And 1 times 1, which is 1, and gives me 6. Let's talk about how to check that over here. I started to mess that up because I was using halves. So my first batch is going to use a whole cup and then 3/4. My second batch is going to use a whole cup and 3/4. My third batch is going to use a whole cup and 3/4. Fourth batch, 1 3/4. Fifth batch, 1 3/4. And then I had 1, 2, 3, 4/4 I didn't color in. That would make another whole cup. And then another 3/4 over here. If I color it all in, this also ends up getting divided into 6. I did a very poor job of explaining that. I should have drawn the pictures bigger. But the idea is you should be able to take all of those and divide them up and just kind of look at the picture and figure out how many batches that you could make. I will hopefully re-record this next year and do a better job with that.